Alright, so remember our last video when we're aiming to set up the AWS bridge mode with the static ports on the host to be able to set up a DNS record and our services communicate, and we hate the very frustrating limitation that ECS service discovery is not registered within ECS service when the network mode is bridge host. That was frustrating, but the exciting news were that I have found this one. Yes, we can enable night trunking, so-called neutral, I don't care. So our current configuration uses T4G small. I think it's 1 CPU, 2 gigs of RAM. It will only support 3 or 4 instances. But if we increase it to medium, which will give us 2 CPU and 4 gigs of RAM, we enable 12 tasks per instance, which is really sufficient and fair, but that's not a problem. So what I want to do right now, I want to just get rid of all the port mappings. We don't need them anymore. So we entering the AWS VPC network mode, which is really good. And I'm really excited about it because now we will be able to have, we don't need to have unique ports across all of our cluster. The ports can duplicate and we don't care because each of these services will have its own unique IP address within our virtual private cloud. So we don't need these anymore, and the life will be much easier and better. Why? Because we don't care about which ports we're using. We can use the same port for everything and we just don't mind. And also, each of these services will have its own network configuration. So we can configure which subnet the service is running into. We can configure who can access this service. We have good network level configuration here, gives us more control. So what we're gonna do right now, we're gonna go back to our previous code where we just did lots of stuff to configure the AWS bridge mode, and now we want to change it back to VPC. So it's frustrating going back and forth. I got fed up with it so far. But I hope this solution will be final and we won't hit any limits because the last one was really unpredictable to need it. ECS will disable using a records for bridge mode. From here, from what I discovered, we should be really good there. So what are we gonna do today? So a couple things going to happen. First of all, we need to enable neutral. It's just a piece of Terraform code. Then we will update instance types. So why we need to do these? First of all, we want to use the instances with more resource capacity. And second, we want, after updating neutral, we need to recreate our instances for them to take in effect. So we will kill both rabbits here. And third one, we need to update all ECS to use AWS VPC. And that's it, and deploy it. So now, we've done a decent chunk of work so far, and I don't want to throw it away during the last session. So what I'm gonna do, let me check. Yes, just lots of stuff here. Really lots of. So what I want to do, I'll create another branch. I'll add bridge suffix to the branch, and now I can simply add all these changes and commit them. Cool. Yes, now we have it here, and I will get back to our previous branch. So we'll literally revert all the changes we made, but I'm also saving them. So if we'll need to reference something in future or get back to this approach, we always have it saved, no version control. What we have now. So the first thing, as we have here, we want to enable nitro. I just made the quick check and found that it should be pronounced nitro, not nitro. We need to enable nitro. So we need to update this default account settings of ECS. Yes, and there should be the setting. There is a setting AWS VPC trunking. It calls increase Linux container instance network interfaces. Yes, that's the one what we want to enable. So we basically will go ahead and create this resource. So in our source code, I think we should put it into ECS cluster because it's ECS related resource. So I'll open the ECS cluster, just scroll down to the, well, actually I'll put it on the top because this is something you should take obvious. And then copy this one over. Done. So we have it enabled. Yes. I'll go ahead and apply it. There are a couple challenges with application because right now we have our previous system's bridge mode set up, and the application of the current system will make us to reverse everything back, and this reversion operation might cause some issues. I think the only issues we'll face will be with load balancer target groups, so same as we had last time, so we'll just manually create them. So anyways, I'll run the Terraform apply and then see what will happen here. Let's have a quick look about the resources that will be changed here. So we'll create this setting. Cool, that's what I want to do. The security group of ECS instance will be updated. Of course, it will be reverted to the previous settings. We don't mind them yet. Let's keep them as it is. Yes, the ports of the listeners will be reverted to the previous ones. Well, actually, we can think here which port should we use. Yeah, so there are not any standard protocol that require specific port ranges for UDP. Technically and practically assign any kind of port to UDP endpoint. Yes, there are some high-level protocols that usually have the convention to use some specific ports, but I don't mind. Maybe I think I'll update them back to 9001 just to keep them consistent, because our application uses 9000 and I don't want listeners to be recreated. I like the idea of 9000, so let me go here, but I lost. So we have listeners and they're running this. Yeah, so we'll create 9000 and 9001 respectively, and we'll be good here. This thing will change. Let me cancel this, apply run again. This one should be better. Scroll up. This one is good. We discussed it so far. So listeners still be updated, but not recreated. That's fine, because target group will be updated. That's okay. If target group will be recreated, that's totally fair. We expect it. Another target group recreated. Security group will be created. Yep, let's have it created. We'll eventually move it inside our module with ECS service anyways. Thus definition will be replaced. Service discovery. Yep. I hate this one. So let me think about it. So for the nets, couple of things. So to avoid any kind of conflicts, let me do a couple of things up front. So let me delete listeners because they will cause issues. The target groups will not be recreated. Being bad guys again today by doing ClickOps manual without Terraform. And let me, in the cloud map, let me detach the nets. It doesn't have any services. That's good because he also attached last time. Perfect. So I think now we're good. Now we can run the apply and make things happen well. Just a quick checkup. Config with trunking good. Security group good. Yes, listener will be created because we just deleted it. Target group will be replaced. Security group created. Everything else we don't care. Let's do it. Great. Everything has been applied. So we've done the first step. It was really smooth. So I'll go ahead and check if we have listeners properly configured in our load balancer. I have 2 listeners with proper ports. I love it. So this one is done. Now let's update instance type. And this one is really straightforward. So if you go here to our configuration, we just replace this one. And we don't need 3 instances. 2 will be fine because they are medium, they are larger ones. So we just balance them. 2 will be fine. And let's do this. And this operation might take a while, but we'll do it. So basically, if you go to EC2 instances, so you can see that we have 3 instances running. And we never create them manually. I have another video for it. If you're creating EC2 instances manually in AWS for your production environment, you using AWS wrong way, stop it, get out of AWS or use it in a proper way. So we will update them to be large and decrease them to 2. And we will change the settings of the auto-scaling group. So the auto-scaling group will actually deprovision all of these instances and provision to others instead. So we'll do it right now. Just make another Terraform apply. Yes, and here we can see clearly that we updated everything. Yes, and this operation will take a while until all the instances deprovision or provision. So let's wait. So the changes has been applied so far. So when I take a look on my instances after a couple of hours, I can see that they're still running small. One has been eliminated because we decreased them to 2 and still small. So I think the problem is that by default, it does not kill the existing running instances, it just deprovisions one. And then for the future instance, it will be spin up all the larger ones. So to this current use case, which should never be done on the production use case, we can simply delete those two instances, and then I will, after scaling group and ECS capacity provider, will automatically provision them. Again, if you have the production environment, you will need to create some strategy to basically provision new instances and deprovision old ones. I don't want to bother about it right now. So what I'm gonna do, I'll simply go ahead and just terminate them. I'm not worried about that. I'm not yet on production. Well, actually, you see what it says to us, that it will do graceful shutdown. Let's see. So maybe what we'll do is start creating the new instances instead, these old ones, and that will be graceful shutdown. Yes, let's do it that way and see. I'm just curious. So it will start the operation. So you're shutting down, and the operation of shutting down will consist that, well, if it really gracefully shuts down, that autoscaler or capacity provider should spin up the new instance first with the new instance type we just specified, which was, I guess, medium. Move all of the compute, all the containers, all the tasks to the new instance, and then shut down the existing one. Yes, you can see it do it. So it spin up the medium one. The medium one is running so far. Now it will move all the tasks there, and this one is terminated. That's great. So that's outstanding. Now we have this one. Why are we doing a restart? Because when we enable the truncating of IP addresses, to make in this setting will not make effect on existing running instances. So that's why we need to basically terminate all instances and make new ones running. So with instance terminating, new one is created instead, but there actually should be two created. So maybe it creates them one by one. We'll see. I don't know. These two terminated will create larger one that allows us to host up to 12 services with network interfaces and unlimited services without network interfaces. Of course, it's not unlimited because you're limited to the resource compute, but that's another story. So let's wait until it's live. And then if it's live, we can simply switch to the awsvpc mode in everywhere, and we'll be really glad and excited about it. In the meanwhile, while it's reprovisioning, we have another one provisioning. That's great news. So 2 instances immediately provisioned by AWS autoscaler or ECS capacity provider, whatever. So that's exciting news. We have now better instances, and let's go. What we're gonna do, we'll set up the awsvpc for everything. So I'll go to this service first, and let's check what we're gonna change. So we don't need this anymore because we will always use the port. So we have a traffic port. Let's use, oops, no, that's not what I meant to do. And we set here, and just, that's our address. That's terrific. So let's move further. Here, we don't need, this one is also obsolete. Security group IDs. Well, what I would say is that the security group should be created individually per instance. So I'll delete this one. I'll remove security group inside. Network mode, no more configurable network mode. We force AWS VPC, so it's contrary to what we did last time. Let's now observe the code and see where we need to inject some changes. So that's good. So network mode, we just hardcode VPC here. That's great. So we'll use traffic ports all the time here because now it's just a different story. We don't need this anymore. I'm great about it. So DNS records, we don't need. We'll use A all the time and TL10. We don't need to be dynamic anymore. Network configuration will be static now as well, because, well, let's do the auto highlight. I'm curious. It requires only subnets. Yep. So we'll do it like this, and then security groups. That's the interesting one. So now we need to move the security group inside here. So previously we have security group configured over here, and I want to move it inside of the module because now everything will have security group. Well, actually, we should be cautious about, because not all these services will have the interface that not all the services will have network interface. So how we define if service has network interface? Only when we're creating the service discovery. So if we do not create service discovery, we don't need this. So if we do not create service discovery, do we need? Well, actually, yes, there might be the case. For instance, in our current configuration, there is a case when we have an ingest service and it doesn't have service discovery, it does not have internal endpoint, but it has the network interface because it has the endpoint that is used for connecting load balancer to it. So it's not necessarily true. So if we want to expose any port, even internal, even monitoring port, we must have some type of interface. And my question is how we should handle it. How do we know if the service should not have any network interface? And by any, no service discovery, no DNS, no anything. So it doesn't have any even ports. Literally, we can have the case when the service does not have port assigned, right? So it doesn't have the traffic port, it doesn't have additional ports, anything. So in this case, we treat this service as non-network service. So it could not act as a server, it acts only as a client. So what I'm gonna do, I'm gonna tell that if we have traffic port or additional ports, then we should have network configuration. If we do, we don't care. The thing is, I'm still concerned about, so if I remove this network configuration for those services that does not have ports, because we'll have a couple of them eventually, I'm not sure if I will run the ECS task with the AWS VPC configuration, right? Because it will try to assign IP address to it. Yeah, so we can simply set the network configuration none. That makes sense. So let's do it. But then in the traffic port, let me go to the variables. So we have variable traffic port. Let's make it by default 0. So it's optional. There might be services that do not expose network. So if traffic port doesn't equal 0, then we create this guy. And the security subnets in the security group, we already have AWS security group. And yes, let's call it service. And then let me think how to call it properly. So we'll definitely start off this service name kebab plus conf. But yes, I just want to know that. So this belongs to this kind of service, which is an ECS service and belongs to this environment. That's the good naming. So we'll fix this stuff. I think, yes, we will have something similar than last time where we accept all of the configuration about inbound and outbound traffic via this stuff. But I'll leave it for now. So AWS security group called service, and that will be it. So this network configuration is not necessarily not only this one. So we also need to check the length of war additional ports doesn't equal 0. Or, so basically if traffic port is not 0 or additional port is not 0, we should create network configuration. Otherwise, we don't care. So then we need to do the same. The security group then will be created optional by the same condition. Well, actually, it's worth creating the local variable. So what I'm gonna do, I'll create something called expose network interface. So literally this one will explain this condition. So because we're using it all the time, I think it makes more sense to name it properly. So now if you go here, I say count local expose network interface, yes, otherwise 0. And then there was security group. I'll copy it over and use here the same, like this, much better. Yes, and then I need to use ID like this. That's great. That's fine. Service registers. That's fine. Another thing, in task definition. Yes, again. Otherwise, none. And let me double check the documentation to make sure that we allowed to set none here, because I don't remember. Actually, we need to go to AWS yes, so this will be this one. And then we need to search for, no, it's not AWS config, sorry. We can use none. Cool. So none, if you're not exposing that now, we just do not expose network and that's it. That's great. Cool. So we are good here. There is one place we're not good yet, is this one. So let me think. Environment. White complains about it. The variable's not good. Just config, of course. Config. And config should also have VPC ID. It doesn't have, so we'll add it, which will be string. Yep. Like this. So we'll go config VPC ID. That's great. And we'll configure this stuff in a minute. I think we're good here. So now let's go and configure variables ingress rules. So that will be the type of this variable will be the list of objects. And then yes, we can literally say port protocol and side blocks. No, we can also specify security groups. Let me dig the docs as well. So security groups like this. Amazing. So what I'm gonna do, I say port is number. Then we have protocol that is optional string with default of TCP, because we have only one use case of non-TCP, right? So we still have it, so we need to make it configurable. Side blocks, let me check how to pronounce it. So CIDR blocks, let's call it CIDR blocks. So this is the list of string, optional, first of all, optional list of strings, otherwise it's empty. And security groups, right? So if we jump here, we can copy this one, optional list of string, otherwise empty. I think these are ingress rules. Now we can create something similar for the egress rules. Egress. Yes, and this variable as well, it's an optional one. I'd like to enforce setting up the ingress rules and egress rules for everything. But the only case when this one will be irrelevant is when we have services without network interface. So then we don't need these rules. And so what I was thinking that we might have by default ingress rules that allow all internal traffic, but then I realized no, let's have by default that does not allow anything. That's the best practice. So default one will not allow anything. So let me egress. I'm curious, like egress. So with egress, we can specify which services can access what. So I think always we can specify that this service can talk to this one. We allow it only to talk to this one. But then what if we want some service to go to some external third-party API, talk to something, right? We need to talk to internet. And in that case, we're specifying the side blocks, aka IP addresses of the NAT gateway. So it means that it can talk to NAT gateway, and NAT gateway will drive him to the internet. That's at least my assumption at the moment. If we want to have some more specific like access control, let's say we want only this task to access only the endpoint of Google API. If I don't know, probably ECS will allow us to configure that. We'll need to configure it on the NAT gateway level, maybe, I don't know. Because I was previously configuring it in Kubernetes and I was able to configure it based on the host name. But anyways, so I think port, protocol, cyberbox, security groups, I think that's pretty much stays the same. So we have egress rules, default. Amazing. Then we need to create dynamic statements for the ingresses. Yes. So ingress rules. So the content now, let's copy these over and paste dynamic values. So it would be ingress value, port, protocol, ingress value, protocol, ingress value, side blocks, and then we forgot security groups. So for those who not aware, let's say we have let me open this diagram. We have two services. So we want Ingest Blue to communicate to NATs. So NATs has the security group that prevents from accessing it. In the security group, to allow Ingest to communicate to it, we need to whitelist the security group ID of the ingest, because Ingest Blue could have dynamic IP addresses. If provision, the IP address will change all the time. But the security group ID on the security group of the ID of the Ingestors Blue security group that will be added to the security group of the NATs will define allow this guy access this. And this is how we specify. So for instance, if it's NATs, we specify in this list the security group ID of the ingestible. So that's how we configure ingress. For egress, I'll copy because it's the only thing we need to. Yeah, let me do it in a fancy way, like this one. Yep. Yes. Oh, let me check one more time. Ingress. Yes. Cool. So let's have a dynamic security group. So I think we should be good here. Now all of our services are just really outstanding. Let me go. So I've added VPC ID recently here. Oh, that should be, sorry, should be string here, not the list of the strings. I think we're good to go. Yes, so this one is no more relevant. This dude is also, I'll keep him because I'll still need it for the reference bar. So let me set up the commands. So ingress rules. Yes, so let's start with port equals 9000. Then side blocks, we should protocol UDP. We need to allow specific AP addresses to access 9000 port for the UDP use case. That's one port. Another thing, we should allow the health check. The health check goes to 5000. It is TCP, so I'll delete it. And I'll use the PC side block. Is it string? Yeah, so we must convert it to the list. So this is the ingress rules. That's fine, I think. Let me check if I'm not missing anything. Yes, and then egress rule. So egress rules, yes, we'll need NAT security group ID, security group ID, that will be string. So with egress rules, it's a really interesting case here. So there is one challenge with pessimistic egress rules. While I can simply do the egress rules, let's have it hard-coded. Ideally, we should have it whitelisted, and then... So technically, this is the egress rules I should allow. So I only should allow access for the port of the nets. But this service also accesses S3, as we can see. So it means we need to create somehow a way to access him S3. And this could be done by creating the S3 AWS gateway endpoint, and then we can specify it by prefix list. I don't want to overcomplicate it right now. I don't think it's, from security standpoint, these kind of setups are usually required in some security assessment protocols. For most of the use cases, this is just another layer of security that might be relevant, I don't know. So what I'm gonna do, I will make REST rules open. So what I'm basically done here is I said that with this config, by having port by 0, I say, okay, this service, okay, why it has the name, the Gmax ingester service, can access any port, any protocol within our virtual private cloud. So it means NAS, and it means the S3. Well, for the S3, we need to create the S3 endpoint, because right now S3 is a public address, so it's not, it will not work, but we'll do right now. So I think then we have really pessimistic REST rules. We can just use the, so we'll consider them more fine-grained, so then we specify the exact port, services, so on. For now, I'll leave it as it is. These statements are deprecated. So I think we are good here. So we can move to the couple more things we need to change. I think nothing needs to be changed on the load balancer level. We are good here. So let me just take a look on the rules again. Yes, great. So I think nothing. What we need to change, we need to add the gateway. So let's go to VPC, create new file called endpoints. So what is this? This is the AWS VPC endpoint. Why we need to do this? Let me quickly explain. So we in our AWS VPC, and yes, and let's move this guy a bit further away, and let's wrap it into another box that called AWS. So this box called AWS. So we have S3. So let me just zoom in so we won't distract you. So S3 is service that is located in AWS, but it is located outside of VPC. So when our service wants to access the S3, right, it needs to, so it has the domain name of the S3. That's how it acts. Like shit. So this is the, how can I move it like this? So this is the endpoint it used to access it. But this service also needs to resolve this endpoint, right? So this endpoint points to public IP address. So it means there is some DNS server located or whatever. Well, I suppose it is located somewhere in AWS. Let's call it DNS. So it first needs to go to DNS outside. Let's make it gray so it won't confuse you. Or goes, and then he goes here. But our VPC also has internal DNS that is in VPC. And if our service, so the problem is that now to access this one, we need to go so-called to internet. So we have the, I want to be black. We have something called NET gateway. And there is another video on explaining how this works. Please check in the description. So NET gateway is something that allows our services to talk to the internet, our private services. So it must go through the NET gateway to get the DNS. And then, so literally what happens that this request now made via NET gateway like this. And the first problem is that when we need to upload a large file to S3, the NET gateway will charge us on the traffic. So I think the egress traffic is fine when we don't load the file, and charges will be significantly if we don't load terabytes, petabytes of data. So to avoid that, we create something S3 endpoint. And what S3 endpoint does, it simply creates a record in our internal DNS. So now we do not go to this DNS. Let me just create a new one. So now we have our service goes to internal DNS to resolve this one. Let me gray it out a bit. Yep. And it uses the S3. Well, let me do it like this. It makes more sense. So it uses the endpoint, it goes through the S3 endpoint to access VPC. So literally what happens that we are not leaving our virtual private cloud to access S3. So literally S3 exists in a virtual private cloud. We can treat it that way. We're not paying for excessive traffic. So cost optimization, the primary reason of it, but in our case, it also that we do not allow this guy to talk outside of the internet. We only allow him to talk internally to the services. And as far as S3 is now our internal service, this S3 endpoint helps us to solve also the security issue. This is just a bit of an explanation of what it is and why we're using it. So yes, let's use the proper values here. Now this one. Region, do I have the region here? I should have one now. No, I don't have a region. Probably a region. No, unfortunately not. So let me go. Let's do it from here like this. Now I have the region. I can just put it here. So I'll use data, this region, current region. It's highlighted red because I think the writer doesn't pick up latest version of Terraform because it's not duplicate row table ID. So that's interesting one. Policy, we don't need policy for that. We just applied for everything. Row tables. So we need to gather the row tables. I'm curious if we create row tables. If we create here just one set of row tables, private, they should all have row tables as well. So what I'm gonna do is here I need to basically copy over these row tables IDs or concatenate them. We'll add it to everything. And we need somehow to get, so we have AWS row table private everything ID. Yep, so we apply it to every row table we have. So we don't need to do anything. So every request that goes to this endpoint within accessing S3 bucket within our region will be forwarded via this, and we're really good here. So I think that one is fixed now. We have the S3 endpoint. And final thing we need to, but I think we're missing something here. Let's fix our locals. So we need to VPC ID here as well. We merge VPC ID. That's it. So that's the fix. Missing something here. Let's check what we're missing. Why not highlighting? Oh, that's frustrating. Not security group ID. We don't need this anymore. Not anymore, but for now. So let me go to this one and delete it. We'll use it later, not now. So if you go here, then we are fine. So this guy now, we need to add the ingress and egress rules. So what we're gonna do essentially, we will in ingress rules, we will specify the exact IP addresses that will access the NAS, but for now I'll do it in the simple way. So I'll do the default one, ports equals 0, protocol, let's have TCP only, and then cider blocks, let's have only VPC. And well, technically these guys shouldn't have any egress, right? That's why maybe I'm wrong, but it doesn't have any egress. It doesn't talk to anyone, so I'll remove any egress rules for now, and everyone within our private cloud can access him, so I think that's fine. Just want to check one thing from port to port. Yes. Hold on, I made a mistake. Here we should have 422, but now that's fine. Eventually we maybe need to export this one, but we just allow access to 422 everyone in the cloud. So I think we're good here. We've added everything we needed, so let's give a try of the deployment. Now we have lots of unsupported arguments, expected hitting security. Oh yeah, my bad. ECS service. Let me check. So yes, that was just a tiny typo. Turn everything red. Good. So no syntax errors. Let's have a look what we're gonna be doing, because it's really interesting. Let's go all the way up. Cool. So we're adding some nets here, network config. That's fair enough for the service net. Yep. Nets, that's definition replaced. Yes, that's totally fine. The network mode will change to AWS VPC. That's what we expect. The security group will be created for the nets that will allow 422 access room, but via TCP protocol from A1 in private cloud. That's totally express. Wow, mistake. Here should be egress rules. Yep, that was a mistake. I've spotted. That's why I love doing plan review all the time, the thorough plan review when you apply something. All right, cool. Let's go. Ingress, we don't have egress. That's great. Just ingress. That's outstanding. Service for nets. We'll have a record. That's okay. This is the discovery service. We might have troubles with that. Anyways, we'll sort it later. Endpoint for S3, 4 row tables. Totally fair. I hope these are the all tables we have. Let me double check, because I was thinking we have table per private per public plus. I was thinking we have table per public per private plus. Oh no. Per subnet, and we have 3 subnets in this region. So we have 6 subnets in total, 3 public, 3 private. Then let's check row tables. 1, 2, 3, 4. We have 1 public and 3 private. That's fine. Then we're good here. That's good. Gmax service will be updated because we'll add new security group and remove this one. Then we'll have new net endpoint. That's expected. Then new security group for the blue, for the red one. And let's check to egress. Allows egress to anything in the cloud, in the virtual cloud. Then inbound, right now it's access from anywhere. To 9000 we will whitelist it with our clients' IP addresses later on. And also internal access from private cloud to the 5000 to let NAT gateway, sorry, not the NAT gateway, network load balancer to process health checks. Tags, same here. I think it's good. I doubt that this setup will pass without errors, but let's give it a try. Oh, here you go. That's what I wanted to get. Applying, right? Pretty much sure that the apply won't be smooth. Yes, we see the first error because the service discovery service is attached. We need to detach it. We already have faced it for a couple of times. So I'll go to AWS Cloud Map Service, actually responsible for hosting all of that. Yes, and then I'll detach the nets. Oh, it can't. Why? Because it's attached to the service. So let's go to ECS first. Add the service nets. We'll update the service discovery. Yep. Use service discovery. No, just don't use it for now. Yes, we'll need to wait probably a couple minutes until this make an effect. Well, not necessarily. No, I think it's available right now, so let's give it a try again. No, it still doesn't work. Service contain register instances. Maybe we need to wait for a bit. Before I start, we need to wait a couple of minutes. Succeeded now. So let's go back and delete this guy again. He's gone now. Let's give another shot. Terraform apply here. Good to go. So the problem is that it wants to create the A record for the ECS service that still uses SRE configuration. Let me try it again, because it might be just a timeout issue. If not, then I'll probably just destroy the service. Same again. So I'll go ahead and destroy the service. Just delete the service and that's it. It will recreate it, because I was still expecting it to be recreated, so I don't care. This operation will take a while, because when you destroy a service, it usually stucks here for a while. So destroy the service and then run the Terraform. I don't understand this, because we have the same thing again. Creating ECS service operation. The value specifying the service registries do not require value for container port remove. Oh, I think I know the issue. Let me just double check. Yes. No, that's definition. So this container port is not relevant here. Sorry, that was my bad. I forgot. It's just for this thing is only relevant for whatever breach mode as service. So we have another error. Missing require argument. The argument container port is required. Shit. Oh no, that's disaster. Oh, it deleted in the wrong place. Pardon me again. I must delete the service registry, not the load balancer. That was my bad. Let's do it again. Alright, so yes, now we should be good. So let's go and check to AWS what's going on. So the service nets must appear. It doesn't have any tasks running, but I'm pretty much sure that the one is provisioning so far. Yep. We can dig in and take a look on the logs, and we have an issue. Why? Because there is an error while retrieving logs from log stream. That's fine, I don't care this error. It should disappear by itself when the server will spin up. AWS might have stuff like that, just confusing internal shit. We'll see, maybe it's something wrong on our side. So we have this running for 2 hours because they are in the same awsvpc. I want to check right now if our load balancer has successful health check. So I'm in here. I'll click the load balancer. This is a load balancer. We have the UDPs, and I open the target group. I want to check the health checks. That's what I'm interested in. It's healthy. It's really exciting. It's healthy. And another one, healthy. Really excited. Yes, cool. So let's go back to ECS and observe how the nets will spin up. So what's going on with the nets? We don't know yet. Let's check if any updates with the logs. No, they are still stuck. Yes, so there might be some issues. Well, let's wait. It requires a couple of minutes for him to spin up. So task, just check any information in progress, any events here. Service has started, so no errors so far. Oh, we see the logs. That's exciting. So we can jump to the task itself, because this, that's weird. That's just some glitch of AWS, I think, because the service level shows logs and this one doesn't. It's still provisioning, just waiting probably last couple of minutes until the health check will succeed. Well, let me check actually if these logs were not confusing. So when they come, yes, they are, no, they are old ones. So this is not the current logs. These are logs half hour ago. So these are irrelevant ones. Actually, we might have some issues. From what I see, we can have some issues because it could not access. Oh, is it nets? Hold on. It's nets. It's running. It's up to date. Everything looks good. Let's wait for the health checks to succeed. Oh, status rank. That's exciting. Not yet healthy, so the health checks are accelerating. So why we have, oh, we want to, this one, oh, some restart started of these services because these are inactives and they got replaced by the ECS. So this one is healthy, that's exciting. Gmax is running, that's also exciting. It's not yet healthy, but let's wait for the final health check. Everything seems to be good. So literally I can open the logs of these and I should see what I see. So it has health and HTTP status code 503. Health check is failing. Yeah, health check is failing. That's what I see. And let me check. They don't have any updates so far, but from what I see, the logs show that it's failing. So the health, they say setting HTTP status code 503. S3, so it cannot access S3, right? That might be the issue. So I know probably what the issue, our restrictive policies. So what I'm gonna do, let me do a quick fix. So I will allow egress to access everything. Let's go here and we have egress, and let's say egress access everything. It will solve the issue. I'm pretty much sure there is some other stuff, endpoint or whatever, so I don't want to dig into it. Let's keep things simple. It's so much. This one is pretty much fast one, so it has. Oh, it's healthy now. Let me check. No, it has been dropped away 2 hours ago, 6 minutes ago. So this one is healthy and running. I'm excited about it. The one we just had that was attempted to start has disappeared, and I think because the health checks failed. Here you go. 4 minutes ago, it has been unhealthy. So, oh, it's healthy now. It's only registering. So your fix has been applied, but the duty is deactivating. I hope that it will give it another try. Didn't have to refresh, so I need to click it manually. So they deactivated the dude, but now it's healthy because I fixed security group. That was funny. Still, which one? It was red one. So I go to the services and check the red one and the deployment status. So the deployment is in progress. So hopefully it tries again. It's not failed. It's in progress. It will try again. We can check it right now. Let's go back to the cluster and select tasks. Yes, it's not yet there. Well, in the meanwhile, I can open the logs of these and check if we have any issues with the nets. So previously, if you probably scroll down a bit, there should be messages like nets is down, so you can't connect to the nets. Yes. No, that's not this one. This is HTTP health check. There was some my place around. I think that is up so far. Can't find any messages because it's just 2 minutes. So only show we can go. Let's this one. No, even this one is not yet there. It's 46, so apparently it has been fixed so far. Let us go and go to our phone. So you can see we had this message. So what I'm gonna do, I'll go to the CloudWatch. So the health check was attempting to connect to the net and it was not able because we had previously network issues. Now hopefully these network issues are solved, and I want to confirm that it's solved. So insights, not insights, log insights. Yeah, so I'll go to group name. Let's have the red check, last hour. All right, cool. Now let's use the, I don't remember this query language. I had it. They had AI prompt before that will allow me to modify the query. So let me go and do it myself. Just added this string, nothing here. Nets maybe, nothing, and shit. We have some Gmax. It's case sensitive. So we can see the last one was an hour ago. Is it UTC? So it should represent in incorrect way. So it was like 51, now it's 54. So it was 3 minutes ago. No, sorry, wrong one. This one. I hope I no. I want to copy this piece of text. Please, AWS, please. All right, so we can see the last one was 10 minutes ago. Yes. So the good news are that we don't have these messages, means that we can connect to nets, and I'm super excited because the last message was 10 minutes ago. And I'll go back to ECS and I check if they have restarted. 3 running. Yeah, so the blue one has been restarted, the right one not yet. I'll forcefully restart it, so I'll delete it so it will spin up the new one. But the good news that we have solved everything we wanted to solve. We can basically check, so all the tasks running in one instance so far. What I want to check if I'll be able to spin up more containers, right? So what if, let's do it in the following way. Now it's running and I want to test the hypothesis, basically this thing. I want to make sure that I can create, so we on the medium, right? So in the medium, we should have only one, but we only have 2 with network interface. So I think we already confirmed our assumption. Let me just double check my, oh, this is the terminal that obstructs me the view. Yes, so I'm gonna copy. Let's check how we see. So this one is spinning up. So I was just digging some other docs and I found that actually per one ANI we can have 4 IP addresses. So it means even without trunking enabled, we can have 12 containers per instance, which is sufficient. That's my assumption. So I think this one is healthy. Yellow groups doesn't still exist, it's provisioning, but I think we're really good here. So let me check the infrastructure. Ranked is not ranked. I'm curious if it will put into this one or into this one. Rank into this one. So I doubt that the trunking might not work. Well, technically it's obvious that it distributes the task across multiple instances to balance the load. But I want to check if I can put more tasks here. So I think what we have here is, because the instance I'm using is not listed here, T4G. I'm worried that there might be an issue. I think everything is working well. We have everything running. Even if our infrastructure is not yet utilizes trunking, so we have limited amount of instances per tasks per instance, we can always change the instance that allows us more. They are pretty. We can try any one of these lists. I think we can find something that suits us here based on the description. The idea is that we now have this deployment, we validated proof of concepts, and we are excited about what we have here. So we have now solid deployment that works, and yep, that's really good. And it was signing out. All right, so getting back to our messy drawing here, we used the approach with AWS VPC, and we confirm that it works. It has some limitations on the AWS network level, but we can mitigate them with selecting the proper instances and images. So I think we are fine here. Thanks for watching this video. Yes, I'll be releasing more videos similar like these with the further development of complicated deployment architectures in the AWS ECS and Kubernetes as well. So please subscribe to my channel to not miss it. Thank you so much. And if you like this video, please click the like button.